Hi guys, welcome back to Aisha's Academy, and I'll be going through the probability statistics, but for the foundation calculator paper. I've already done the higher one, which is on the channel down below. So yeah, just stay tuned if this is useful for you. Okay, so question one, which has come out a bit funny, but it basically says that the pictogram shows information about number of pictures sold in an art shop in each of January, February, and March. And it wants us to write down the number of pictures sold in January. So it says that one box represents 8 pictures. So we can see that January has 3 full boxes, so it'll be 8 times 3, and it's a calculator paper, so you could just put that into your calculator, which is 24 pictures. And then it says 12 pictures were sold in April, so it wants us to show this information in a pictogram. So if we know that one box is equal to 8, so then if you did 12 take away 8 to find out how much is left, you've got 4 pictures left. So we know that 4 is half of 8, so we could just draw half a box, and then that's represented 12 pictures, because we've got the 8 here represented by the full box and the 4 here represented by the half a box. So then now it says, what was the total number of pictures sold in these 4 months? So we've worked out that January was 24. For February, we've got 3.5 boxes. So we already know that 3 boxes is 24, but half a box is 4. So then 24 plus 4 is 28 in February. Then March has 2 boxes, which 2 times 8 is 16. Plus a half a box, which is 4, so that's 20. So 20 boxes sold in March, and we've already been told that April is 12. So in your calculator, you would do 24 plus 28 plus 20 plus 12. I'm just going to work out quickly with that one. So 60, 72, 84. So then that would be 84 boxes. Oh, sorry, 84 pictures. So moving on to question two. So question says two says that in Adam's garden, the flowers are only red, white, or yellow or blue, and it says the chart shows the number of red flowers, the number of white flowers, and the number of yellow flowers. And it says the total number of flowers is 30. And so from this graph, it wants us to work out the number of blue flowers. So let's work out the number of each color. So there are 8 red flowers. There are 10 white flowers. There are 5 yellow flowers. So 8 plus 10 plus 5 would leave us with 23. And so if we've got 30 in total, so 30 minus 23 would give us the total number of blue flowers, which is 7. I should write that down here. Then now it wants us to write down the mode. So as a recap, mode means most common. So we need to work out the most common color. So from this information, the color with the most common, the color with the highest number of flowers is white. So therefore, we can happily say that white was the most common. Okay. So then going on to question 3, I'm just going to write out the numbers out properly. So it says work out the median. So we know median is the middle value, but only the middle value when the numbers are written in chronological order, aka from smallest first to largest. So we're going to rewrite this order. So that would be 3, then the 4, then the 4, then the 6, then the 8, then the 9. So just double check I have 6 numbers, which I do, and I've got everything written down correctly. So then with our median, it's always your total number, which would be 6 plus 1 over 2. Which would be 3.5. So then our median in this case would be there. So it would be the number between 4 and 6, which would be 5. So 5 would be our median. Then it says Aisha. Hey, Aisha. Anyways, let me not get gassed by my own name. It says Aisha picks at random one of the numbers. So it says, what is the probability that she picks an odd number? So looking at the list, the only odd numbers were 3 and 9. The rest were even. not evening. So 2 out of 6 of the numbers were odd. So we could simplify that fraction. So divide both the top and the bottom by 2. Now leave us with the third. So the probability of her picking an odd number is 1 out of 3 chance. Okay, so moving on to the next one, it says Clara has 5 cards, and it goes on to say that there is a number on each card. 2 of the numbers are hidden though, and it says the mode of the 5 cards is 3, and it says the mean of the 5 numbers is 5. So it wants us to work out the 2 numbers that are hidden. Well, we know mode is most common. So if we know that the most common number is 3, we already have 1 3, then essentially you could either have like another 3 as a card and then we don't know what the other number is, or it could also be a 3 as well. So we would need at least one extra 3. So at the moment we've got 3 plus 3 plus 8 plus 5. We're going to call this one X because we don't know what it is. So it says that the mean is 5. So working out the mean, you always do your total of all the numbers added up over how much you have, and then that would give you your mean. So then if it's all this hidden number, so I'm going to put that as a question mark, divided by 5 is equal to 5, then that question mark must be equal to 25, because 25 divided by 5 would give us our mean of 5. So 3 plus 3 plus 8 plus 5 plus x is equal to 25. Now I'm going to rearrange this to work out what this potential card could be. So then 3 plus 3 is 6. 6 plus 8 is 14. 14 plus 5 is 19. So 19 plus x is equal to 25. You lot could just use your calculator. I'm just choosing not to. So then x would be equal to 6. So essentially, in order to fit the criteria that they've given us, the other card would be 6. So just to double check that, 19, 25, yes. So then by having the other card as 6 and the other card as 3, that would suit the information of the mode being 3, and it would also suit the information about the mean of the 5 numbers being 5. So therefore the 2 hidden numbers are 3 and 6. Then it says the probability that a new fridge has a fault is 0.015, and it wants us to work out the probability the fridge does not have a fault. So we know total probability equals 1. So the probability that it doesn't have a fault, it will be 1 minus 0.015, and in your calculator that should give you 0.985. And then moving on to question 5, it says a teacher asked the students in year 6 what type of transport they use to get to school. And it says the dual bar chart shows some of the results. So it says, what is the most popular type of transport used by the boys? So we're basically looking for the biggest bar out of the boys. And as we can see, that would be walking. So it would be walking, as the boys is the grey charts. Then it goes on to say, I'll write it down here. Goes on to say that 7 girls walk to school, and it wants us to show this on a dual bar chart. Dual just means 2, and as you can see, for each mode of transport, they all have 2 bars. The only one that has a bar missing is walking, and so we're going to fulfill that information based on what they've given us. So they said that 7 girls walk to school. So all we need to do is draw a bar up to 7, representing girls, and because girls are stripes, you just draw stripes in between it, and that's literally it. And then for part C, it says more of the students get to school by car than bus. How many more? Well, the total of students that go by car, we've got 5 boys that go by car and 9 girls that go by car. That's a total of 14. Then by bus, we've got 6 boys that go by bus and 4 girls that go by bus. So that's a total of 10. So how many more you would work out the difference? So you would do 14 minus 10, which would give you 4. So therefore, 4 more boys and girls go to school by car than bus. And then part D, it says the number of students in year 5 is the same as the number of students in year 6. So what is the total number of students in year 5 and year 6? Well, this bar chart represents all the students that travel by year 6. So if you work out the total of year 6 and you know that the total of year 6 is the same as year 5, you can just work out the total of year 6 and multiply it by 2. So we already know that 14 students go by car, 10 of them go by bus. Let me zoom in. 10 of them go by bus. So you got 9 plus 7 here, so 16 of them, sorry, walk. You've got 4 and then the 1, so 5 of them cycle, and then you've got 2 and you've got the 1, so 3 of them go by other. So in your calculator, you would nicely put, just writing it down here, 14 plus 10 plus 16 plus 5 plus 3. And I'm just going to quickly do it. So that would be 30 plus 10, which is 40. So that'll be 48. So then you've got 48 students just in year 6. So then for year 5 and year 6, you would do 48 times 2, and that would leave you with an answer of 96. So you've got a total of 96 students in year 5 and in year 6. So moving on to question 6, it says, here is a four-sided spinner. And basically, even though this table is a bit mashed up, but realistically, think of it as a normal table. It's saying the table shows the probabilities that when the spinner is spun, it will land on a 1, a 3, or a 4. And it's showing us the numbers, and it's showing us the probabilities, except the probability of it landing on a 2 is missing. So it wants us to work out the probability of it landing on a 2. So again, this goes to my point that total probability adds up to 1. So you would literally do 1 minus 0.2 minus 0.4 minus 0.1, and that would leave you with an answer of 0.3. So that's the probability of it landing on a 2. Then it says which number, so if I zoom in, it says which number is the spinner least likely to land on? Well, it's least likely to land on the one with the smallest probability. And as we can see from our table, the one with the smallest probability is the probability of its landing on a 4, because of a 4 is 0.1, which is the smallest number. Then it says Jake is going to spin the spinner 60 times. And it wants us to estimate the probability that will land on a 1. So number of times is equal to, which I think I mentioned this in the high paper, is equal to your probability multiplied by the total number. So that's going to be 0.1 times 60, and 0.1 by times 60 is 6. So then the probability that will land on a 1 is 6 times. Okay, then moving on. It says that you've got a stem and leaf diagram. Again, it's come out a bit funny, but we can work through this. And it says below gives information about the ages of people in a social club. So it wants us to find the range of these ages. So we know that range is your largest value, take away your smallest value. So the largest value in the table is the 74. So remember, with your stem and leaves, you've always got your tens, and then you've got your units. So then it would be 74, and the smallest value is 31. So 74 minus 31 would leave you with an answer of 43. So 43 would be the range. Then in question 8, it says 200 people live in a village. 23 people do not have a garden. 10 males do not have a garden. 95 people are male. So it wants us to use this information to complete the frequency tree. So first of all, it's split up in those that do not have a garden and those that do have a garden. So it says 23 people do not have a garden. So 23 people do not have a garden. The other people would have a garden. So to work out that, you would put into your calculator 200 minus 23, and that should leave you with 177. So now we know that 177 people do have a garden. Now, out of those that don't have a garden, we already know that 10 of them are male that don't have a garden. So the rest that would have a garden that are female, that would not have a garden that are female, would be 23 minus 10, which is 13. Then out of the males that do have a garden, it says that 95 people are male. We know that 10 of them don't have a garden. So 95 minus 10 is 85. So 85 of these lot would have a garden out of the males. And so out of the females that do have a garden, it'll be 177 minus 85. And in our calculators, quickly, that would leave us with 177 minus 85. 92. So I'll leave us with 92. I'm just double checking I'm right. Yeah. Okay. Then it then goes on to say that one of the people who do not have a guardian is chosen at random. So it wants us to write down the probability that this person is a female. So out of the total that do not have the guardian that are female, there's 13 out of 200 of them. So that would be the probability, and we can't really simplify that any further. So that would be our final answer. Then it goes on to say in question 9, the table shows information about the number of points scored by 30 students in a quiz. So it wants us to find the modal number of points. So we've come across this term before, so mode most common. So in terms of frequency tables, your mode is basically the one with the highest frequency. Because if you've got the highest frequency, it's the most common. So the one with the highest frequency is when you've got two number of points, because it's got 7. So the modal number of points would be 2. Then it says work out the total number of points scored. So then to work out the total number, you're going to multiply. So make a column here quickly, where we're going to multiply number of points times frequency. So first of all, 0 times 4 is just going to be 0. Then 1 times 3 is 3. 2 times 7 is 14. 3 times 5 is 15. 6 times 4 is 24, and 5 times 5 is 25. So then using your calculator, we're going to add that all together. So I'm going to rub this out, sorry, just so we can write the total underneath there. So I add them all together. So that would be 3 plus 14 plus 15 plus 24 plus 25. That will leave you with an answer of 81. So you've got a total of 81 points. Then moving on to question 10. So question 10 says that we've got our Venn diagram, and it says that E is the numbers between 1 and 25, and it says that A is 2, 8, 10, and 14, B is 6, 8, 20, and then C is 8, 18, 20, 22. So then now it wants us to complete the Venn diagram. So in order for what A, B, and C share in common, which is this part here, we need to find if there's any numbers in common that they all have. So having a look, they all have an 8. So that would go there, and we can just cross that out so we don't get confused. So let's have a look. So section A has a 2, and no other one has a 2, so that's going to be on its ones. Section A has a 10, and no other one has a 10, so that's going to be on its ones too. And section A also has a 14, which no other one has a 14, so that's going to be on its ones too. Section B has a 6, the only one that does, so 6 there. Section B and C both share a 20, so 20 would go there. And then section C has an 18 and a 22, which no other sections have, so that would go there. And then because the outside is even numbers between 1 and 25, we're going to work them out gradually. So 2 is already there. 2 was there. 4 is not there, so that will go there. 6 is already there. 8 is there. 10, 12 is not there. 14 is there. 16 is not there. 18 is there, 20 is there, 22 is there, 24 is not there. And between 1 and 25, you would have 12 even numbers. So let's double check. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So then it says a number is chosen at random from E, and it says find the probability that the number is between A and B. So realistically, if it was between A and B solely, then it would only occupy that part. And so realistically, let's be honest with ourselves, there is nothing in that part, so it's just going to be 0 out of 12. Yeah, because we've got 12 numbers in total. So the probability would just be 0 because there's nothing that is just strictly A and B. You've got A, B, and C, but if you've got that sign where it's going down, it means just A and B only. So then 11, which then goes on to say this table gives information about the time in seconds and 18 students to run a race. Again, the tables mash up, but we move. So then it says work out an estimate for the mean time. So here it says give your answer correct to 3 significant figures. So in terms of working out the mean time, first of all, we're going to work out the midpoint of the slots in times, which was 7.5, 12.5, 17.5, and 22.5. And then we're going to do our midpoints multiplied by our frequency. So then that would be 7.5, 25. Also, you'd be using your calculators for these. I'm not expecting you to do these in your head. So 122.5, 180. So then, now that we've done that, we're gonna work out the totals of that. So that would be 180 times, add that, which gives us 335. And then the 335 will be divided by the total number of students we have, which is 18. So divide that by 18, we end up with 18. So I don't know why I find that funny. 18.6. So rounded up to three significant figures. So then the mean time is 18.6. I mean, that kind of makes sense because when you look at the table, like, that would fit within that. And, that looks like a nice hefty mean. So yeah, whenever it comes to these questions of working out mean from frequency tables, work out your midpoint of these columns. Work out your midpoint, do the midpoint times the frequency, add all that together, divided by the total number, and that gives you the mean time. So then moving on to question 12, scatter graphs, love them. So it says one of the points is an outlier, write down the coordinates. Outlier just means it's out of the squad. It's not part of everything else. So it's this one here. So the coordinates would be 10 and then 19. So remember, you always write your x before your y value because x comes before y in the alphabet. Then for all the other points, it wants us to write down the correlation. So as we can see, everything is going up. So we would call this a positive correlation. Then moving on to part C, it says, on the same day in another British town, the maximum temperature was 16.4 degrees. And it wants us to estimate the number of hours of sunshine in this town on this day. So 16.4 degrees, we need to find it on our graph. So as we can see here, this would be about, if I zoom in for y'all, this one would be about 17. So we can see 1, 2, 3, 4, 5. So for every one, there's like 5 boxes. So then, one box, if you divide by 1 divided by 5, one box is equal to 0.2. So 16.4 would be about here. So if we go across from 16 point, oh my gosh, before we even go across, how could I forget? When it comes to estimating, you have to draw your line of best fit first. Oh my, okay, let's not get too excited. Let me draw this neatly. Okay, we're going to try this again. Bear in mind, on paper, you guys would use a ruler and it'll probably be easier for you. Okay, that's the best we're gonna do, and to be honest, I'm okay with that. I'm actually okay with it. So you get 1 mark from your line of best fit, and your other mark is when you go down and across or up and across. In this case, in this case we're going across. Sorry, bless me, and then down. So then, as we go down, that is giving me about hold on, let me draw this. About 12.9 vibes. So I would say about 12.9 hours of sunshine in a day. So on that day, at that temperature, then it says the weatherman is saying the temperatures are high on days when there's more sunshine. Does the scatter graph support this? Well, yeah, because as we can see, it's a positive correlation. And just to summarize and recap, positive correlation means that if you have one part of the graph going up, you have another bit going up. So as we can see from the graph, its temperature is increasing, number of hours of sunshine is also increasing. So I'd say yeah. So anything that's saying along those lines that I've just basically said, that would give you a mark. So I'm going to say yes, because the graph is a positive correlation. So anything along those lines is fine. Then it says Amina has 2 bags. So it says the first bag has 3 balls, 3 red balls, 7 green balls. Second bag has 5 red balls, 4 green balls. Then it says Amina takes a bag at random from the first bag. Then she takes a bag at random from the second bag. And it wants us to complete the probability tree. So they've kindly drawn it for us. Okay, so just going back to the point, it says that there were 7 green balls in the first bag. So they've actually written out of 10. Oh, yeah. I don't know why that surprised me. So you just write 7 out of 10 because there's 7 green balls. Then, if she's taken out, so here, it shows that if she had taken out, no, it says that in the second bag, there's 5 red balls. So there would be 4 green balls. So 4 out of 9. So then 5 out of 9. 4 out of 9. However, one thing to note here is that it says that she takes a ball from the first green bag, and then it says that she takes a random ball. Okay, yeah, that's that bit complete. Then, moving on, it basically says that it wants us to work out the probability that Amina takes 2 red balls out of the bag. So, having a look at this. So probability that she takes 2 red balls out. Well, there's only one time that she would have done that, which is if she takes out the first bag and she takes out the second bag, right? So then to do that, you would have to do the probability of her taking it out the first bag multiplied by the probability of her taking it out of the second bag, because they're 2 different events, they're 2 different bags. So then whenever you've got 2 different events, you always multiply the probabilities to work out the total. So when it comes to multiplying fractions, you multiply your numerators together and your denominators together. So that'll be 3 times 5, which is 15, over 90. We can simplify that as a fraction, and that'll be 1/6. And that is basically that. So then the probability of her taking out 2 red balls would be 1/6. Then last question of this series. So you've got 4 red bricks with a mean weight of 5 kg and 5 blue bricks with a mean weight of 9 kg. 1 green brick has a weight of 6 kg. And Donna says that the mean weight of the 10 bricks is less than 7 kilograms. Is Donna correct? Well, let's have a look at this. So we've got 10 bricks and it's saying that the mean weight of the bricks is less than 7 grams. So that means that the total weight of all the 10 bricks, so that would be 10 times 7. So total weight should be less than 70 kilograms. So let's get the cracking and see whether she's right. So let's look at the reds, for instance. So the total weight of the reds, we've got 4 red bricks. The mean weight is 5. So 4 times 5 is 20. So we know the total weight of the reds is 20. Okay. So let's have a look at the blues. So the total weight of the blues would be 5 times 9, which is 45. Okay, so we've got 45 kg of total weight of the blues. And then that 1 green, it's just 6 kg. So then if we do the 20 kg plus the 45 kg plus the 6 kg, we end up with, unfortunately, Donna, we do end up with 71 kg. And 71 kg is not less than 70 kg. And now if we work out the mean weight of the 10 bricks, you'd have to do 71 divided by 10 because there's 10 bricks. And that would leave you with 7.1 kg. So 7.1 kg is the actual mean weight of the 10 bricks. Therefore, so close but so far. Therefore, Donna is wrong. And so that comes to the end of this series. I hope that was useful. And we just did it under 30 minutes. Thanks for watching there, guys, and stay tuned for more content.